Whoa, don't be scared. Who are you? You look like a modern grandma.
I'm you.
Me?
You. What? The future you.
And why are you here?
I'm here to tell you the truth.
What truth?
The truth about time.
What about it?
Time is an illusion.
What does that even mean?
It means time is relative.
That was way too dramatic. Let's simplify it. Here's a brief history of physics. Everything was just fine until Einstein came and broke everything into pieces. One of the resulting pieces from his strong physical strike known as the theory of relativity was relative velocity time dilation. Time dilation is the slowing of a moving clock relative to a stationary one. The faster the clock moves, the slower the time it measures. And in case it approaches the speed of light, it stops ticking. Sounds surreal, right? Here's why it works. I'll suppose you're watching this video on your couch. Go do some workout, couch potato. I'll give you one light clock and keep one for me. The light clock ticks every time the light hits the upper surface and comes back to its source. When I start moving, you, the still observer, will see the light in my clock moving diagonally instead of vertically, which means that it travels a longer distance than the distance the light in your clock travels. Therefore, my clock ticks more slowly than your clock does, considering the fact that the speed of light c is a universal constant. But wait, even though it sounds pretty smart, this whole story does not necessarily mean that the actual time dilates as objects move. It only means that the clock takes longer to tick. Oh, my little self, you're still learning about life. See, as you're moving, you don't really notice a difference, since the clock and you are moving with the same velocity. So according to you, the clock ticks every second, let's say, while to the stationary observer, it ticks every second and a half. This is how we calculate the time dilated interval. Sounds even crazier. Let's think about it using the space-time model, which considers time as a fourth dimension of the universe. If Grandma is standing still, she will only move vertically as time passes. And if I travel to a nearby galaxy on a fancy spaceship with a really high velocity, I would move diagonally in the space-time model, since both my time and space are changing. Therefore, my motion through time slows down, because some of it is dedicated to space. So within the time that Grandma can have breakfast, work out, and count the countless wrinkles she's got, I would only be able to tie my shoe. But don't you think this is useless? I mean, who cares? It doesn't really have to do with our real life. You just love to dramatize everything. Remember the last time you used the GPS to go to the nearest public toilet? Yeah? If time dilation weren't considered in the system, you would have stopped a little bit far from the toilet.
You've arrived at your destination.
I missed the coffee of the 2080s! Never mind now. How about time travel? Traveling to the future is possible. Theoretically. But you've come to the past, and how come there are two of the same person? Well, I only exist in theories so far. But who knows? Wait, what? Whoa.